Watch as we take a randomly selected EcoBoost engine and run it through a series of grueling durability tests to prove how tough it is.
Engine fatigue, thermal management, vibration. We're going to test this thing hard.
There's no way that a customer could replicate the same things that we're doing.
I'm pretty impressed. We've got all of our 22 logs up the hill.
He'd come onto the straightaway, roll into that throttle. We'd get a downshift. The engine RPM would jump up 5,000. We'd run 5 to 5,700 RPM full load, just like our durability test. Yeah, full boost.
Full boost.
We're going to be very, very competitive against the V8s in terms of horsepower and torque.
This is a 3.5 liter engine, the EcoBoost is, and it's going head to head with a 5.7 and a 5.3 liter.
It's a game changer, man.
Congratulations, officially finished the Baja 1000.
Engine's running fine. It's ready to go another 165,000 miles.
Now we're bringing EcoBoost engine 44 8AA home to get an inside look at how it's held up.
Ladies and gentlemen, please welcome Ford Motor Company's V6 EcoBoost Chief Engineer, Jim Mazachowski.
Good morning, everybody. And thanks for being here and participating. We are just thrilled to be here and be part of this. There's just a lot of energy and excitement out here. And what we're going to do today is a first for us at an auto show. We're going to tear this engine down real time and live in front of you all. And it just isn't any engine. This is the engine you just saw up there. It's our new EcoBoost V6 engine. It's going to go in our F-150 here in 2011. And part of the prove out and demonstration is what you just saw here. This engine, we built it, first of all, in Cleveland, Ohio, in our Cleveland engine plant. And we pulled it right off the line, the assembly line. And first thing we did was we brought it up to Dearborn and we put it in a test cell. And what we can do there is vary this load and the speed and the temperature. And we tested the engine to replicate 150,000 miles first. And after we did that, we normally would have stopped and said, that's a legitimate durability test. Instead of that, we sent the engine down to Kansas City Assembly Plant. We put it in a stock F-150 truck, and then we exposed it to these tests you just saw. The first thing we did was we gave it to a lumber company out in Oregon. We drove it to Oregon. We gave it to a company. They generally use like a backhoe or a skidder piece of equipment, and they pull logs up the hill after they down them. The F-150 was used with chains. They pulled 55 tons worth of lumber up that hill with that EcoBoost V6. It really demonstrated the low-end torque capability of the engine. After Oregon, we drove it from Oregon to Miami. We put a trailer behind the truck. We put 2 NASCARs in the trailer, 11,300 pounds, which is the trailer tow capability of that truck with that EcoBoost V6 in it. We ran it for 24 hours straight, wide open throttle, pulling 11,300 pounds. After that, we took and drove the truck from Miami to Arizona, and we raced head-to-head with a Chevy Silverado and a Dodge Ram V8 engine. Our EcoBoost V6, we put 9,000 pounds behind all 3 of those trucks. We raced up the hill, who was fastest 0 to 60, and who was fastest up the 3.5 mile, 6% grade road. Our EcoBoost Ford F-150 beat them both for 0 to 60 and up the hill. After that, you'd think we might be done. We did one more thing. We took the engine out, and we gave it to Mike McCarthy and his race team out of Phoenix, Arizona. They put the same engine in his Baja truck, and he raced the Baja 1000, which is 1,062 miles down the Baja Peninsula. in the conditions that you saw there, just dirt and sand and dust and just a brutal track. And 1/3 of the entries in that race don't finish. The EcoBoost V6 and an F-150 did just fine. And what we did after that was took the engine out of Mike's truck. We sent it back up to Dearborn. We put it in the same test cell that we started this whole thing with. And in the beginning, it pulled 365 horsepower. We pulled 364 after all this was done. It pulled 420 foot-pounds of torque in the beginning. It got 420 foot-pounds when it was done. So it's got about 165,000 miles on it right now, and we are going to tear it down. The same engine is right here. We haven't looked inside of it, so we're going to learn just when you guys are going to learn real-time tearing this thing down. So with me are several of my colleagues. What we're going to do, the program after this, it'll last about 45 minutes, and we're going to let you guys come up at the end of it. The parts will be laid out on all the tables. You can talk to some of our engineers, the technicians, and anybody pretty much with this shirt's fair game, okay? So we're excited to be here. I just want to introduce a couple of guys. Chris Brown is our technician, and he's an expert on building them all up, okay? And he knows these engines better than anybody building them up. Chris Rahill tears them all down. So I got the two best guys that know these engines better than anything. And they're going to do it for you live here. Kirk Sheffer is one of my engineers that's an expert on the upper end of the engine. Jeannie Way is one of my experts that knows the bottom end of the engine, so they'll all be available to you afterwards for questions. Several of the other team members are here as well, so we'll all come up and be available to answer questions. You can take pictures of the parts. And last but not least, Phil Fabian is our dynamometer test supervisor, and he's going to also be part of it and tell you a little bit more about the teardown. So, Phil, good morning.
Good morning, Jim. Good morning, everybody. As Jim said, we're going to tear this engine down. Typically, this teardown process takes about 10 hours. When we're done with the durability test, we want to check the critical fasteners, all the torques on them. We take a lot of different measurements on the engine, but in the interest of time, we only have 45 minutes here. These guys are going to blast it apart with impact wrenches. So one of the other things we do, as Jim said, after a durability test, we tear them down. Well, before that, when we finish the durability test, we run what we call post-test checks. And so we'll go ahead and measure the performance of the engine. Now, this engine, as Jim said, finished our durability test, but then we ran all these other torture tests. So we brought it back to Dearborn, put it in the dynamometer, and ran performance on it. Ran the same settings as our advertised power, and as Jim said, made 420 foot-pounds and 364 horsepower. Some of the other things we check when we're looking at this to try to understand the health of the engine before we tear it apart is we look at the compression. So we'll crank the engine over, and we'll see what the compression of the cylinders are. We measured that on this engine, and all the cylinders were in spec. We had one a little bit low, but very close to our specification. Some of the other things we look at is leak down. So actually pressurize the cylinder, and we look for air leaking either past the valves or through into the crankcase. And this engine, again, our target for that is less than 20%. We had one cylinder at 13%. All the rest were in single digits. It's phenomenal that what this engine went through, that the checks were coming up like that. And one of the final checks we do is actually we pressurize the cylinders again, but this time to 1,000 psi. Go ahead and look for leaks, like head gasket leaks and leaks anywhere between the cylinders or out the head gasket throughout the head. So went ahead and pressurized that, run these N2s on it, and again, there were no issues with that. So while they're tearing this engine down, the other thing we're going to do is point out some of the features that make an EcoBoost engine. So one of the first things that makes an EcoBoost engine is the direct injection. And this is a high-pressure fuel pump, direct injected pump, and fuel gets sent to this from the tank pump at 65 psi. This thing's controlled by our powertrain control module and can vary the pressure from that 65 psi all the way up to over 2,000 psi, depending on the demand from the engine. So the fuel comes from this pump here and goes into our stainless steel fuel lines, which then go into the heart of a direct injected engine, which is the injector. And so as opposed to most conventional engines out there with a port injection system where you're spraying fuel into the intake port and it has to go past the valves and everything, we actually use a direct injection technology on this, same as a diesel. So we're spraying the fuel directly into the cylinder, And what that really means to the customer is allows us to keep a higher compression ratio, which means we make more power, get better fuel economy, better emissions out of it. So one of the things that we'll be doing as well as they go through here, there's a few checks that we talked about, and we're going to be showing them up on the board there that we look at, and one of them will be valve lash that we'll go through. I guess the interesting thing is you can tell we've never had this engine apart, so we thought we could get it done in 45 minutes, but it may take a little bit longer here as they got to pry the parts off of it. One of the things that the engine takes advantage of is we use a lot of RTV to seal the engine up, keeps everything very tight. You can see right here looking at it, there's no oil leaks, there haven't been any coolant leaks or anything like that. So after all this abuse, you've got a nice clean engine other than the mud and the dirt that is on it from the Baja 1000.
So, and as Phil had mentioned then too, we'll take a couple measurements, actual measurements, and then we'll do some visual inspection too. The teardowns that we generally do back in the lab are much more thorough, but for the purposes of here, we're going to actually we're going to get ready to take our first one. So this first one we're going to measure is valve lash or valve clearance. The engine is a direct acting mechanical bucket engine, so as the camshaft rotates to open and close the valves, it works against the bucket tappet. So this first measurement we're going to take is called valve lash, and it's a measure of how much wear is between the camshaft and the bucket, as well as how much wear is between the valve and the seat. So the first measurement we're going to get here is 0.17 on the intake, Chris? 0.17 on the intake? 0.38. Okay, and 0.38 on the exhaust. And what we're showing here is what Kirk is showing up there is we have a new build specification on where the engine's built, and then we've expanded that to show the wear region and what we allow for allowable wear. And this engine actually is still within the new build specification. You can see up there where he's putting the X's is just our 0-hour build spec. So it hasn't even gotten into really the wear limits yet. So it is still very, very healthy and has a lot of miles to go, at least from this standpoint on the overhead and the upper end of the engine. So very, very good first data point. What they're going to do next is take the front cover off, and we'll get a look at the front of the engine and take another kind of measurement on the front for chain wear. And then most of our inspections visually will be in how the piston looks, how the bearings look, and because those are really sort of keys that give an indication of wear. So,
let's talk about while they're going to get the front cover off. It'll probably take a little bit. We talked about the valve lash or measuring the valve lash, and the reason it's so critical on an engine like this is as the lash wears out or gets out of the spec, we'll lose performance, we lose fuel economy, so there's some ill effects. So it's always important for us that after we run a durability test or have gone through a test like this, that the lash is in spec. So throughout the development of an engine, if you have issues like that, you can go ahead and modify different either valve materials or valve seat materials to make sure those are in spec. So the other thing that we're going to work on doing is actually getting the turbocharger off as well. And we can talk about kind of the boost part of EcoBoost. This is the heart of the EcoBoost engine, and it's what allows this 3.5-liter engine, EcoBoost engine, to make 420 foot-pounds at only 2,500 RPM and 365 horsepower. This thing's at 3.5 liter compared to our V8 competitors. We make over 104 horsepower per liter